Well, hello YouTubers, and welcome back to the Holtz Mitchell channel and another episode in the woodworking series. Now, this particular episode will apply also to some of you folks out there who do metalworking, so if you're at all interested in saws and metalworking, by all means stay tuned because there are some aspects of this that do apply to you guys as well. So stick around for the good stuff. But first and foremost, this episode is going to be dealing with Sawtooth Geometry, and for some of you out there it can be quite daunting, especially for you home gamers out there who are on the trying to weigh the decision, what kind of saw blade should I buy? Should I buy saw blade A or saw blade B? It all depends on greatly what kind of a product that you're intending to put out, and then B, the type of material you're working with. And so we'll be covering a large section of that. Now granted, we're not going to cover it all today, but we will cover the basics and try to get into some of the weeds in places on some of the nitty-gritty. So I have my other camera here to kind of give some detailed video. There'll be some stills as well, so I'll probably put the stills again at the end. I'll blend them in here also during the course of this, so that we can kind of gauge what's going on here. So anyway, let me I need to go grab a straight edge here and I'll bring the camera around here and show you guys some of the intricacies of tooth geometry and how it applies to you. So let me continue on here before I bring the camera around on some of the tooth geometry. We make a differentiation of 4 basic tooth forms, and this is mostly something you'll see in the European market. I'm not sure how this kind of stuff translates into the U.S. market. For those folks of you who are in the U.S., this may apply to you folks down under that are following along with the channel. If you have different information, by all means chime in the comment section below and throw your 2 cents worth in, because it all helps give everybody a better idea of what's going on, especially in your particular neck of the woods. Now, for the European market here, we make the distinction of pretty much a KV and a KU, and a PV and a PU tooth. And the reason for that, and I'll show you here when I bring the camera around, the K-tooth is more or less a saw primarily for cross cuts. It has a unique tooth geometry. Some people call it wolf's tooth. That's also a common name for it. And there's also ripping applications for it, but by and large that's just for manufactured goods or manufactured lumber, like particle board, OSB, plywood, and that sort of thing. The P tooth is actually more for longitudinal cuts in natural wood, i.e., boards, just regular, grown lumber that you're cutting up. Now, I don't have a P tooth here. I was looking over in the filing room, and we just don't have one. All we have is K-tooth today. I do have a P-tooth in this metal saw here, so this will have to kind of stand in for the P form, or the P form of the tooth. So here we have a P-tooth saw, and if you look at my arm sleeve here, the silhouette against the saw will overlay that tooth with a letter. Now this is a PV, and the V standing for nothing in particular. It just means the overall distance between the teeth. Now, as you notice here, you got you know, a pretty close tooth count here. You know, a lot of close distance between the teeth, and so this is considered a PV. Although you could, for the metal working aspect of it, call this a PU because of the shape of the gullet. So then we have the K tooth, and here we have a typical K tooth. This is just the profile. This is a saw that's actually thought to do plywood and OSB. So, and then a K tooth for ingrown wood. As you can see, the form is similar to the other one. This one's just for cross cuts. So let's move the camera around here again so you guys can get a better idea for what all these things are for. About my shoulder there. Some teeth have a shape like this. We'll see that here in a little bit. These are for extremely hard materials like the coated melamine, or the melamine coated MDF, plywood, stuff like that, because the melamine is, although it's a plastic, it's extremely hard, and yes, it is actually as hard as steel. And as this tooth passes through, it needs a negative rake angle on the front of the tooth in order to maintain its edge. Then others, oops, I'm going to have to get out the old glass cleaner here. I guess this. Then others follow. Now this is, of course, goes to the diameter right to the center point of the saw. You know, this would be, the arbor hole or arbor bore, and so that relates to that. And then others. So this is a neutral, and then you have teeth that have what's called a positive rake angle. So here we're going to start with the saw that basically started it all, and that's the saw that actually cuts normal wood. The rest of these are all engineered wood products, and so again, you need special blades for that. But for those folks out there who are just processing their own lumber, their own wood, this is the chapter of this video that's going to be best for you. Now, we saw this blade early on. I'll try to turn it with the other camera here so you can see it. It has, this is it's not HSS, it's a chrome vanadium blade, and as you can see, it's been burnt before, so these have a tendency to burn, but if you push them too hard. However, if you treat them right, they'll give you some fairly decent results. You won't get a very smooth cut with this saw. I mean, it'll cut smooth, but the problem is you'll still see the tool marks in the wood, which you won't see with your carbide blades. Now, this is a carbide tipped blade, and so some of you folks out there who like the carbides, just be aware that you don't have any side clearance on the side of the teeth, and as your blade dulls, you're creating much more pressure on your wood fiber, and it pushes away, and then as the blade comes past, or the back, the cutting edge of the tooth passes through the wood, that fiber expands again and then rubs up against the side of the tooth, and that's what's creating the burn in your cut. And so to counter some of the burning, they try to put a little taper on the teeth, although that taper is only a few 10,000ths of an inch, a few thousandths of a millimeter. So it is effective in harder woods, but in softer woods it has a tendency to burn. So just be aware of that. And as the blade gets hot, it'll accumulate pitch behind the tooth. You'll see that in some of your cuts, I'm sure. And so you're going to be out there cleaning your blade. So if you clean your blade, use a brass bristled brush and not a steel wire bristle. So that way you don't dull the edge of your teeth when you're cleaning your blade. But anyway, back to the normal wood saw. These teeth have set in them, which so with this saw blade we have a 15 millimeter spacing, which means this is more suitable for material that is harder to cut and then generates a smaller chip during during its travel through the material. So if this would be, like I say, more suitable for a cross-cut saw, for like a radial arm saw and that sort of thing. For longitudinal cut, you'd need a much bigger tooth with much bigger spacing so that you don't burn up your saw. Now here we have some carbide tip blades, and this one here, and these all have different functions. Now, as I mentioned before, the finer or the harder your material is, the finer the tooth is you're going to have to have. Now in plywoods, you have hardwood plywoods like this. This is out of a bed frame. This is actually like a box spring. The Europeans like to make these things, and this is out of beechwood. So this is a beechwood plywood that has an arch to it, and this is the blade you'd want to use to cut this kind of stuff, where you have real close a tooth separation. And then also you have a positive rake, and then you have an alternating. You can't see that. I'll do some close-up in a still right here. So then you have an alternating grind on the tooth cover here, on the top of the tooth. Let me see, I got to put on my other eyeballs here to see what I'm looking at. That's what I'm. Okay, this is a blade that you can use for not only this plywood, but this is also quite well suited for coated plywoods, coated OSB, and hard coated materials because of the tooth geometry here. You have the ridge of the tooth is going to be ground a little different in alternating patterns. So. Let's see here. Then we have this guy here. Like I said, this is one of those safety saw blades, and as you can see, you have the ridge of the tooth doesn't slope off very well. So this means this is one of those quote-unquote anti-kickback saws, and you can't really feed this guy too terribly fast without running into problems. Now this has an alternating grind, and picture is still right here. So as you can see, one side of the tooth is raised, and then the opposite side is raised, and so forth. And that's what the case was with this guy here. It also has raised teeth where they alternate. So this blade is more suited for particle board, that kind of thing. particle board is one of those materials that has a lot of sand in it, and so the sand, when the blade encounters that sand, it has a tendency to dull fairly rapidly. And so when you're cutting that particle board with your regular, softwood saw, that's why it's getting dull so fast, is because of that sand in there. Now OSB, you can cut this kind of stuff with this OSB with this kind of blade too, although it's really not all that well suited. This will cut MDF as well, but plywoods, it won't do so good in it. It'll burn the plywood really fast. So then there's also this other engineered product. This is a sandwich board, and you have a solid wood core that's sometimes been finger jointed. You can see the joint right here, and then it has MDF covering. Sometimes they'll have an OSB core with a veneered coating on top of it. That's also a product I've used in the past, and I'm not real thrilled about it because when you run a screw into it, it has a tendency to split, especially if you're running a screw into the face end of the board. So this is a material that you can cut with this kind of blade, although I don't recommend it because you'll see burning on the face of the wood. The MDF part will be okay. You'll need a different type of saw blade, more along the lines of this. I don't have a coarser coarse tooth blade than this, unfortunately, right now at hand. So I'm using this little guy here. So the next blade we're going to take a look at here, we have some veneers, and so here's another rule of thumb: the thinner your material is, the finer the tooth spacing is going to end up being. Now, if any of you have ever worked with with veneer before and used hand tools, the Veneer Saw has a real fine tooth, and so does this guy here. So let's bring this real close. This is only like 1/8 inch spacing on this tooth, and this is an HSS tool or HSS blade. And you don't see HSS in woodworking settings very often, but this is the one exception where you're going to see it. Normally HSS, that's kind of reserved for steel and metals, sometimes plastics, depending on what kind of plastic you have. You can cut this melamine coated stuff with this kind of a blade as well, because the HSS can take the abuse, although we have special blades for melamine coating. And I mentioned that over there at the whiteboard, so we'll get into that saw blade here right shortly. So here's a piece of coated MDF. Now you need, for MDF, MDF is fairly soft, but you still need a fairly fine tooth blade, and that's where this guy comes in. Now also notice there's slots here, and you got a little copper plug, and you'll see that quite often in saws. Here there's just a little laser cut into the little question mark cut into it. Here we have a slot and a hole. And now the reason they do that is to prevent this from happening. This blade was heated to the breaking point and it started to crack. So there's a crack here, a crack here. Yeah, there's 2 cracks in it. And so this blade is toast. It can never be used again, because eventually this blade will fail. It'll come apart in the saw and you'll be dodging chunks if you try to use a blade like this. So these are expansion joints to prevent the blade from cracking, because these will get quite hot, especially if you're running them for any length of time. Other blade that we're going to take a look at is this one here, and this blade, like I said, is for cutting this coated melamine or melamine coated material. Now melamine, as I mentioned before, is extremely hard. It's about as hard as steel, and so it's real abrasive and it's really hard on saws. So you'll see that when you're cutting, as on the edge, you'll see how it chips out. Now here's a little tip for you folks out there who don't have the money to buy a special blade for cutting this stuff. If you're only going to do it, once in a blue moon, you can put a piece of masking tape on your cut where you're going to cut this stuff, and that'll prevent large chunks of the melamine from tearing out. Now the other thing you can do is sandwich this stuff where you have two pieces of melamine facing each other in a mirror fashion, and then what you do is you put a double-sided tape over the area that you're going to cut, and then that way as the blade passes through. Now this is just for folks who don't have the money to pick up a negative rake saw blade to cut this kind of stuff. I mean, when you go and look at Freud's catalog, one of these blades, they'll run you anywhere between $100 to $150, $200, depending on the amount of teeth that you have on there, and the type of blade that it is. So it's something you'll have to weigh out. And so when if you're running a lot of this stuff, then by all means it does pay off to pick up the specialty blades. But if you're just doing it once off, that's one little trick that you can employ to deal with tear out on melamine coated stuff or other plastic coated materials. Like this MDF. This MDF here, it actually has a film. This is a foil, a plastic foil that's been applied with hot glue, and so it'll tear out as well. But as you notice here, when you're looking at this type of, when you're looking at the cut, there's no tear out, and because that was cut with one of these type of saws here, with the fine teeth and the alternating teeth. YouTubers, I hope that kind of helps you guys out a little bit in trying to, make a decision what kind of blade to buy for, the home gamers. For the pros out there, some of you guys probably already know this stuff. For those of you who don't, I certainly hope that this helps you along a little bit and is kind of a guide to, make a better choice for your blade blading options, depending on the material that you're working with. Especially in a commercial setting like a cabinet shop or something like that, because you're going to be changing tooling quite frequently depending on the material that you're running, and so I hope that kind of gets you guys a little further down the road. Now, one of the things I forgot to mention, especially like on these these HSS saw blades. These are an inverted taper, which means they are wider at the crest, at the tooth line, than they are towards the arbor. They do have, an arbor ring here, and that is an artificial way to create set or clearance in the teeth. Now again, these HSS saw blades are generally reserved for really, really hard materials like steel, aluminum, in some cases the melamine itself can be cut with this, or other plastics that are extremely hard. So just keep that in mind. Now again, the set on the teeth on the just regular old run-of-the-mill saw blade, that creates the clearance that the saw needs in order to get away from the fiber of the wood as it pushes back into the cut. Now, here's a picture of one of these saws, or two of these saws here, with in regards to the data that's imprinted on them. Now, as you can see, at the top you have 200. That's your tooth count. Or no, sorry. Back up. 200. That's the diameter of the saw. 1.7. That's the thickness. And then by 1.4, no, 1.7 slash 1.4. Now the 1.7 is the width of the tooth, or the carbide portion of the tooth. The 1.4 is the thickness of the blade, and the 32 is the bore diameter. Now the Z80, that is your tooth count. Well, YouTubers, that's a wrap for this episode of Tooth Geometry. In the future, we'll probably go over bandsaws as well. I don't have a bandsaw at hand right now to show you the difference. Like I say, the tooth forms are the same. So you got the K and the P form in your bandsaws. You have stellite tip, you have carbide tip saws. Same thing as, you know, with your circle saws. The only difference is, like I mentioned before, is the skip tooth versus the full comp, which you've heard that probably that term before if you bought a chainsaw chain. And we'll get into chainsaw chains at another video. That's a whole different topic for itself. So we'll get into that at another time. The same thing with bandsaws. But I hope you were able to get a little something out of this. If you have any thoughts, comments, critiques, suggestions, by all means, let loose in the comment section below. If you have additional information supplemental to this monologue, by all means, chip in, chime in. It's always good to hear from the viewership. If you have different experiences, or if you have a unique experience pertaining to this, or observations that you might want to share with the rest of the folks out there, I do implore you to go ahead and put that in the comments. So with that, that's a wrap for today, and I do thank any of you who are allowing the ads to play in the channel. When the videos come on, I had to monetize the channel. I weighed the decision quite lengthily, or at length, and it didn't come easy. I do regret it, but if you can help out the channel a little bit by allowing the ads to play, it certainly will be appreciated. There's some things that I'm trying to finance for the future, and you know, with the ads, there's no money out of your pocket, so if you can spare the time, I can use the dime. So anyway, with that, that's a wrap for today, and we'll hope to see you guys all again very, very soon.